Hey everyone, this is Mayur. Welcome to ML Works. In this video, we'll talk about scaling in machine learning. So, scaling is one of the pre-processing step in an ML pipeline. And why do we need scaling in the first place is to understand how an ML algorithm thinks about features and why scaling helps us in that particular aspect. Okay, so first let us understand how ML algorithm thinks about the features. For instance, consider a few algorithms like KNN and KMeans clustering or PCA. So all these algorithm uses Euclidean distance or you at some point in time use Euclidean distance to identify data points which are closer to it or which helps them in mapping their label with the features. Okay, so that is how this ML works. Okay, now what happens is in these algorithms, okay, these algorithms thinks, okay, if a feature has a higher magnitude of range or values, so these features are important than other features which has low range of values. Now, for instance, you can consider a problem statement where you have features like salary and age. Now, age has a range of 1 to 100 or 150 at max. Okay, and salary has range from thousands to tens of thousand or even million. Okay. Now, when you apply algorithms like K-means or uh, KNN or PCA, so what it does is it gives special importance to salary because of its range, and because of its range, the age gets a lower importance in the whole ML pipeline. Okay, so what we want to do is we want to avoid such bias towards this specific feature because of its range. To avoid that, what we do is we apply scaling. Now, along with that, scaling also helps in neural network when you are trying to train a model. Okay, the parameters try to find the local optima for the parameters. Now, if you have features of different range of values like age and salary, what happens is this to find the parameters of an local optima it becomes difficult since it has to handle all this different range of values. So what we can do is we can scale it and bring it to a range of 0 to 1. And the way the algorithm works is it tries to converge quite quickly when it has range in between 0 to 1. Okay, that is the idea behind applying scaling in neural networks. Now next comes to what different types of approaches in scaling. Okay, there are like a bunch of techniques available for applying scaling for the different types of distribution of data that is present. Okay, so we'll talk about just three of the approaches and then we'll look into how to apply scaling and what happens, okay, if you don't apply scaling to an ML algorithm. Now let's briefly discuss about min-max scaler, standard scaler and robust scaler. So min-max scaler has it says it uses min on max value of a particular feature and it applies scaling into such a way that it shrinks the value of your feature between a range. This range could be 0 to 1 or minus 1 to 1 if you have negative values in your features. So that is the ultimate purpose of this particular scaler. And since it has this min-max values are present, if you have a feature which has outliers, then this scaler might not work very well for that particular scaling aspect. Now, next comes the standard scaler. So this scaler assumes your features are in what normal distribution and it tries to scale the features into a format where the data is centered around 0 with a standard deviation of 1. Okay, that's how it works. And robust scaler is similar to it is since it as it calls it robust scaler. Okay, what it means is it is insensitive to outliers. Okay, what it does is it takes the interquartile range between 25% to 75% and use that as a factor to scale your values in the features. Okay, so that is just basic definition of what all these three different scaling techniques. Now what we'll do is we'll try to load a data set and we'll have some features with a different range of values and some features with a different range, a low range and a high range. Okay, and then we'll see when we apply KNN based algorithm on such a data set with and without scaling, what is the difference in performance. So let's see, first we are loading the data set of load wine. Okay, and then we are turning x and y from there, we are fetching it And then what we do is we import train test split. Then we use min-max scaler, and this is the algorithm which is sensitive to scaling or range of values in a sense. Okay, and then we have classification report. We import all this, and then we split the data set into test and train. And then here we define our scaling, okay, which is min-max scaler. And here we have fit transform and then transform. So first we apply on the X train, and then we apply it on the X test and generate X train scaled and X test scaled. Now we define another algorithm here. Okay, not an algorithm. We define the machine learning classifier here, k nearest neighbor. Okay, with 10 neighbors and n job as -1, and it is called unscaled because we are taking up unscaled features here. We have scaled features again here, underscore scaled. Okay, and we train a model or fit a model here. And similarly, on scaled data set, we apply the same algorithm with the same set of parameters. Now we try to identify, or that we try to see what is the change in terms of performance on a scaled data set and on an unscaled data set. So if you see here X test, it is an unscaled data set, and the performance here is 0.72, which is 72% mean accuracy. Okay, using this algorithm. Now we have scaled model which is fitted on scaled data set. Okay, and we are testing it again. And if we look at here, we get a value of 97.2% mean accuracy. So we can clearly see algorithms which are sensitive to what range of values tend to perform better when you apply scaling. Okay, so this is the end goal of applying scaling in the first place in a machine learning pipeline. I hope you got the point. Okay, thank you.